So today's lesson is basic probability concepts. And what we're going to do is we're going to take a look at how we can apply probability concepts to real world application. So when you talk about terminology, we actually have a bunch of terminology that we got to go over today. And the first thing that we're going to do is we're going to go over a thing called experimental simulation. A simulation is exactly what it sounds like. It's something, a process that models an event. In mathematics, we'd say that it would be a way to kind of codify what would actually happen in the real world, right? Essentially, it's a process that models a real world event. When you hear the concept of a trial, okay, the concept of a trial is you can think of it as a repetition of an experiment or a situation. So, for example, if we go back to what we started with, your example for an experiment or simulation would be the rolling of two dice. So, I'm talking about rolling all the different outcomes of the two dice. One trial would be rolling the two dice once. Okay? Now, when we talk about the outcome, that is just talking about now the result of an experiment could be the individual outcome of one trial or the results of everything from the experiment. Right? So all of the trials put together. Okay? Now, in mathematics for you guys, when you're talking about the results of an experiment, we're talking about all the results, okay? Now, here's the last thing. When we're talking about an event, we're talking about a specific set or a subset of outcome. So, for example, if we were talking about the die, okay, the rolling of the die. So maybe I want to know the outcomes of all of the sums being 4. That's it. That would be a subset, a special event that I would look for. So if I said find all the times 4 comes up as a probability, that is the event that I'm looking for. And now let's get on to the meat and the guts of today's work. All right. So when we're talking about a thing called theoretical probability, that is a ratio of the number of outcomes that make up an event. And we're going to divide that by the total number of outcomes. So it's like this is the event. Think of it this way, the event divided by the outcomes of the experiment. So all of the possibilities. Okay, so you have an event and then you're dividing by its outcomes. So kind of think of that as what you're using for the theoretical probability. When we're talking about the experimental probability, this is just a ratio of the number of outcomes that occurred to the number, not number, let's say the total number. Total number of outcomes. So in this case, imagine that you set up the probability. In this case, you want to think of it as what we want divided by what happened in the experiment. So you can think of it that way as your ratio. Now, one thing that I should let you know that for both of these ratios are calculated as fractions, and the numbers are between 0 and 1. They could also be represented as percentages, and we'll talk about that later. So now, when we talk about all this stuff, we got to talk about the formulas that the theoretical probability and the experimental probability kind of tell us. We call this P of the value A, i.e. the event. What we're looking for is equal to the number of times that A comes up, i.e. the cardinality of A, divided by the cardinality of the superset, i.e. the number of times that we've done our entire number of outcomes or experiments. So just copy this next set of notes down. So you can think of the probability of a P of A being the probability of A happening, right? And then N of A is the number of ways that A's actually happen. So that's why we studied our permutations and combinations from before. And then we also figured out how to use permutation and combinations to find the total number of outcomes without restrictions. So we're going to use that in this unit. So you've already seen this new concept that we call certainty, right? Certainty is an important thing that you've seen before. An example of this would have been when you go and find out about the weather and they talk about the possibility of rain. Okay? All right. Now, certainty is measured from it's a number that tells us how likely something is to occur. Now, when you talk about this stuff is measured in percentage, and the percentage goes from 0 to 100%, or it could be represented as a decimal, which goes from 0 to 1. Okay? Now, let's go over some examples of the work we're going to do today. And what we're going to do is we're going to use some of the math that we used last semester in the last unit to do some of these problems. So if you can show me that you can do some of these problems, I'll change some of your marks on your previous test. As you've actually shown me that you understand permutations and combinations, and now you're combining them with probability. Before we go on, I should say that when we're talking about our probabilities up here, these probabilities are always measured in decimals from 0 to 1, okay? We can also change them into percentages from 0 to 100%. You can do that at any time when we're dealing with probability. All right, let's go on to our problems for the day, and we'll focus on the probabilities of rolling a pair of dice. What I tend to do is I tend to create a grid that represents all of the outcomes of two die. So on the bottom part, this I'll call it die 1, and this is die 2. Okay. Now, because we have these two dies, we can create a Cartesian representation of all the points on the die. So on the die, we have 1, 2, 3, 4, 5, and 6. This chart is going to represent the sum of the dice. Okay. Now, we're going to do the same thing for die 2. We're going to label all of these 6 spots. 1, 2, 3, 4, 5, and then 6. Now that we've got this chart, we can go and take the time and fill out the chart. 1 and 1 is 1 plus 1 is 2. 2 plus 1 is, oh, look here, 3, 4, 5, 6, 7. Now, the cool part about this is if you follow the outside line, you'll be able to if you make one line, you can copy it along the vertical as well. 3, 4, 5, 6, 7. And then now we got 3 and 1. Now let's go 2 and 2. 2 and 2 is 4, but then 2 plus 3 is 5, 6, 7, 8. And then we copy 5, 6, 7, and 8 for its sum. And then we do the same for 3 and 3, 6. And then 7, 8, and 9. Oops, wrong. Got to change that. Can't be 8. It has to be 3 plus 4 is 7, 8, and 9. And we fill out the rest of these ad nauseam. And this chart will literally represent all of the outcomes of literally rolling our dice, our 2 dice. So now let's go and calculate the probability the sum is 4. So if I want to find the probability that the sum is 4, we literally write something like this. Okay, so we write the probability of the, let's say the probability, you could say the sum of 4. Now, the fact is when you go and describe your probabilities, you tend to want to describe it really nicely, i.e. put it in words inside the brackets, which is equal to the number of times that we have 4. Let's see, 4 is here. And the number of times that happens is 1, 2, 3, 3 times. So that goes on the top of our fraction. Divided by 6 times 6 is 36. So 36 possible outcomes, which is 36, which simplifies to 1/12, which you could write as approximately, you could write it as 1/12. The probability is 1/12, or you could write 8.3%. Now to do that, you just got to do 1 divided by 12 and multiply by 100 to get 8.3%. So now let's go and take a look at our chart of all our outcomes. And now let's go into and see if we want a sum of 3 or 10. So 3 or 10 means that they're happening either or. Now the sum, so this part here represents the or, represents the additive rule. Now the additive rule that we studied a long time ago still applies to probabilities, especially when it comes to the number of events. So let's write this out. So the probability of 3 or 4 is equal to, well, we go and find our 4s. So that's 3 spots. So that's 3 plus, for our number of ways, the next thing happens. So that's going to be a 3. And the next spot, so we got this, or a 3 happening as well. So we have to have 3 plus 2 possibilities divided by 36, which is equal to 5 over 36, which doesn't simplify nicely. Or you could write 13.9% as our probability. Now, you'll notice that sometimes I have the fraction, or I could leave it as the decimal. In university, your teacher tends to want to leave your probability as fractions. When we want to understand the concept, we want the percentages, okay? So don't be surprised that you would see something like that in your set of homework. So now we need to calculate the probability of there not being a sum of 6. Now, we can do this by counting all the numbers that aren't 6 for this problem, okay? Now, or you could do this indirectly. So if I wanted to find the probability of the sum of 6, what we can do is we start by finding the total number. So we take the total number of no restrictions, just get all of the possibilities, 36, and we subtract the possibility of not 6. So that tick means not 6. So we take 36 and we subtract the number of times we see 6 in our set. And in that case, there are 5 times that you see 6 in our outcomes. So just to highlight that one more time, we said there were 5 times we see 6 in our outcomes. So here we go. There's our 6s all highlighted. They're 5 times. So literally, we're going to have 36 minus 5 divided by the total number of outcomes, which is 36, which means this is 31 over 36, which gives us about 86.1% probability of the sum not being a 6. So now we're going to experience the last thing. When we're looking at the sum being 13, if you look at your set, the probability of 13 is going to be, well, there's no possibility, so we get the null set, right? So we get 0 over 36, which gives us 0, which means we have a 0% probability of finding a sum of 13 for rolling 2 dice. All right, I'm just going to pause the video here, copy this down, and then we'll move on to the last topic of the day. So now let's talk about some basic probability with sets. So imagine I have this superset S. Given the set S, which has 1, 4, 9, 16, 25, 36, 49, and 64, determine the following possibilities, right? It says picking a number that you can take a square root with. Well, what are the numbers that you can take a square root with? Well, they are, well, you can check 1 can square root, 4 can square root, 9 can square root, 16 can square root, perfect, 36, 49, and 64. Oh, wow, that's all of them. So that's all of the elements in the set can be square rooted. So the possibility of a square root. So here's what we would write for this calculation. The possibility of a square root is equal to, well, 8 over 8, which is 1, which really means 100% possibility of that happening. Okay? Now, picking an event, let's take a look at this. Picking an event number that is divisible by 2. Let's see. What numbers are divisible by 2? In our set, we have the set. Let's call this, so it's divisible by 2. We got 4, we have 16, we have 36, and 64. Now, the number of this is equal to 4. So that means the probability of an even number is given by 4 divided by 8, which is 0.5. Or if we do this right, we would reduce this to 1/2. Or you could write it as 50%. So you would say this is a 50% probability that you could divide something by 2. So now let's go and figure out how we calculate the possibility of being odd. So you know that the probability of being odd is the same as the probability of not being even. So remember, this means find the complement of being even. Okay, so I want the complement of it being even, which means we have, well, we can put this as a percentage, right? So we go 100% minus 50% is equal to 50%. And we're done. Now, let's take a look at picking a number that's divisible by 5 or 6. So if we're looking for a number that's divisible by 5 or 6, let's go for it. So there's only 2 possibilities for that happening. So there's only 2 possibilities for that happening. So a number that's divisible by 5 in that entire set is 25. And then another number that's divisible by 6 is 36. So there's only those 2 numbers, right? So if I want the probability of a number divisible by 5 or 6, you would say this is 2 over 8, which is a total of 1 over 4, which is equal to 50% 25% probability. And we're done. Your homework is found in the package, and it's lesson 2, question number 2. All right, get them done.